what we're going to be doing here is we're going to be starting to warm up to solve trigonometric equations. Trigonometric equations is one of the highlights of the trigonometry unit in grade 11 and 12. So it may take some getting used to, but the first step to solve a trigonometric equation is really isolating or solving for the trigonometric ratio first. Now, when I say trigonometric ratio, I just mean sine theta in this. So I'm going to solve for sine theta. One trick that I'm going to be using is I'm going to be using the substitution method. So it's really quite easy. I just let A equal to sine theta, and I solve for A. So if sine theta is equal to A, I can turn this equation as 6 plus 9A is equal to 0. Continue on to solving. So 6 plus 9A is equal to 0. I can subtract 6 from both sides. And then I can just divide both sides by 9. Now that wasn't too easy. It was really a two-step algebra problem. We may want to reduce this fraction, and we can reduce it. A is equal to negative 2/3. Now, keep in mind that we're not really solving for A. We're trying to solve for the trigonometric ratio, sine. So if A is equal to 2/3, what I can do is I can just reintroduce, instead of saying A, I can reintroduce sine, because sine is A, is equal to negative 2/3. So that's isolating for the ratio using substitution. The next thing I may want to try out, though, and I would encourage you to do this besides every substitution, is try to work with the trigonometric ratio directly. So for instance, what am I going to try to isolate? I'm going to try to isolate sine theta. So I'm going to start off by subtracting 6 to both sides. Now sine theta is exactly like a variable. The next step is sine times a variable is equal to negative 6. I'm going to divide both sides by 9. I'm going to simplify that trigonometric ratio, and I would get sine theta is equal to negative 2/3. So we end up with the same result, but two different methods. And substitution is really handy whenever you encounter a difficult trigonometric ratio, or maybe something that feels like it's one step away from solving. So please use the substitution method. So let me go on to this next trigonometric ratio. Now I am going to solve for tangent in this manner, because that's the trigonometric ratio. And it kind of seems crazy. Tangent squared theta plus 3 tan theta plus 2 is equal to 0. Well, how could I solve for tan theta? Well, it seems confusing, so let's just try the substitution method. B is equal to tan theta. When I substitute B for tan theta, tan squared theta turns into B squared. Plus 3 tan theta turns into 3B. 2, well, there's no substitution needed there, it's just 2. And then I have a quadratic equation that I could use to solve, and we've solved many of these before. So what we notice is that the coefficient in front of the b squared is 1. So I'm going to use the product sum rule by factoring this. What two numbers multiply to 2 but add to 3? Well, that would be plus 1 plus 2. So from this, I can employ the zero product property to say that b plus 1 is equal to 0, or b plus 2 is equal to 0, and finally end up with b can be equal to negative 1 and b can be negative 2. Now keep in mind, I wasn't really solving for b. That's not the main goal. My main goal was, remember, tan theta. So I'm going to make that substitution back. Instead of writing b is equal to negative 1, I just reintroduce tan theta. So tan theta is equal to negative 1, or tan theta is equal to negative 2. Now, I'm going to try this again, the mirror image of it, but just not substituting. So, pardon me, I have tan squared theta plus 3 tan theta plus 2 is equal to 0. Now I understand that this is quite difficult to do and see, but the substitution method sort of primes what we're doing. So I have tan squared theta plus 3 tan theta plus 2 is equal to 0. What I notice is that my coefficient in front of my ratio squared is 1. So I get to use the sum product rule. For example, what two ratios multiply together to give you tan squared? Well, that's just simply tan and tan. If you multiply tan theta with tan theta, you get tan squared theta. Now, what two numbers multiply to 2? Well, that's plus and minus 2, or plus 2 plus 1, or negative 2, negative 1. So I think I'm just going to try this out, and this is more of trial and error, but it certainly works out that I get tan theta plus 1 is equal to 0, and tan theta plus 2 is equal to 0. We could revisit this by saying we recognize that the coefficient in front of the squared ratio is 1. So what two numbers multiply to 2 but add to 3? 2 and 1, using the product sum rule. So now I'm one step away from solving. So I'm just going to say tan theta. I'm just going to subtract 1 from this ratio, from both sides of this ratio. So tan theta is equal to negative 1. Moving to this ratio over here, I'm going to subtract 2 to both sides. So I get tan theta is equal to negative 2. Same result. All right. So I hope you're following along, because I find this really, really interesting, how we can play this substitution game to solve something that appears harder. And I particularly don't like this very much, to be honest with you. It seems really, really difficult. However, I'm just going to play the substitution game. I'm just going to say, let A equal to tan theta. Let B equal to sine theta. So I can take on the left-hand side, so that would be A, and that would be B, and 3 times A. Now this is important, because a lot of people make an error, so in their reasoning. Pardon me, I'm so sorry. So you cannot divide this, both sides, by A. You mustn't, because it's an equation. I would encourage you to use the zero product property. And I could do that by subtracting 3A to both sides. Now I ask ourselves, does there exist a common factor? Sure, the common factor is A. When you factor out A, the expression that is left is B minus 3. So let's just multiply that out quickly in our heads. A times B minus 3 is AB minus 3A. So that works out. Now I'm just going to use the zero product property. Maybe put that in brackets. And what I can see is A can be equal to 0, or B can be equal to plus 3. Or we can just call it 3. How about that? So I'm just going to revisit what was my substitution. So A was tan theta. So I guess I'm saying tan theta is equal to 0, or sine theta is equal to 3. All right, last but not least, I'm just going to try to work with the trigonometric ratios all by themselves. I'm going to use the exact same language. I'm going to try to anyways. So the first thing I'm going to do is I'm going to use the zero product property. The necessary condition to use the zero product property is I need to have one side equal to 0. So I believe I should subtract 3 tan theta from both sides. There we have it. Now I'm going to ask myself, does there exist a common factor? So it might take some time, and you might not get there, and that's okay. There, I'm just going to highlight common things. Does there exist a common factor? Yeah, sure, tan theta. I hope you can see it. Both. This is a binomial, and both terms of the binomial had tan theta. So I'm going to factor that out. So if I factor out tan theta, I'm just simply left with, well, if you factor out tan theta, you're left with sine theta minus 3 is equal to 0. Now solving for tan theta, I'm going to use the zero product property. I have two factors. I can solve where tan theta is equal to 0. Or my second factor, I have sine theta minus 3 is equal to 0. So this is we're solving one trig ratio right now. So tan theta is equal to 0. Now I'm trying to solve for sine theta minus 3 is equal to 0. So I'm just going to add 3 to both sides. So those are my trigonometric ratios solved.